Hello, everyone. In the next 2 minutes, the live lesson will commence. So, hello, everyone. You're welcome to this lesson. In this lesson, we'll be looking into some Cambridge IGCSE past questions on the topic we completed last week, Friday, that is number concepts. So this is the first question here. You have the first question. We are giving some numbers: 3.565, root 196, 8, root 7, and 12. So from the list, write down a number that is of the following. So we need to apply the knowledge of our number concepts to this to see how we can um, apply the knowledge to solve the questions uh, listed before us. So kindly give me a few seconds. My pen is not writing, so I want to look into it. Sorry, I'm still trying to figure it out. It's not writing. Hello, sorry. I'm still trying to sort it out. Okay, so the pen is back, so I can write now. So from the list, we are asked to write down a number that is a multiple of 3. So in our previous lesson, we discussed multiples of a number, and we said the multiples of a given number are God, 1, 3, 3 times 2, 6, 3 times 3, 9, 3 times 4, 12, 3 times 5, 15, and so on and so forth. So from the listed numbers here, so a multiple of 3 we can see here is 12. So we write 12 here. That's a multiple of 3. Then a cube number. So a cube number is got when you multiply an integer by itself 3 times. Take for instance, you have 1 by 1 by 1. The answer is 1. So 1 is a cube number. 2 by 2 by 2. You have 8. 8 is a cube number. Okay, so 3 by 3 by 3. You have 27. 27 is a cube number. So from the listed number here, so 8 will be the cube number here. So we can easily pick 8. So I'll write 8 here. So a prime number. So in our previous lesson, we discussed a prime number. A prime number is a number that has two factors, only two factors. That is 1 and itself. Okay. So for this one now, if you look at 5 here, is a prime number because it has only two factors, 1 and itself. So I'll pick 5 here. An irrational number. We said an irrational number is a number that cannot be written as a fraction. Okay, and we gave some examples where we can cite or find our irrational numbers. So roots of some numbers, that is numbers that are not perfect square or a cube, a perfect cube, and so on and so forth. So 7, root 7 will be an irrational number. So let's go to question 2 here. So here we also write down a square number greater than 10. So a square number greater than 10, if you have the square numbers now, it will be 1 times 1. 1 is a square number. 2 times 2, 4. 4 is a square number. 3 times 3, you have 9. 9 is a square number. 4 times 4, you have 16. 16 is a square number. 5 times 5, you have 25. 25 is a square number. So here now, I want to get a square number greater than 10. Okay, so if I like, I can pick 16. If I like, I can pick 25. If I like, I can pick 36, and so on and so forth. So I'll pick 16 as it is a square number greater than 10. Then next is an irrational number. So from our previous class, that is last week, so we discussed this very well. So you can pick square root of 2 or square root of 3, square root of 5, or you can pick a cube number. You can pick a cube root of, let's say, 4, cube root of 5, cube root of 7, and so on and so forth. So let's go to the next one. Here we are to write down a prime number between 50 and 60. So if you look at 50, for instance, okay, 50 is not a prime number because it does not have exactly two factors. The next one will be 51. If you look at 51, 51 is not a prime number because apart from 1 and 51, another factor will be 3 because 3 can go in 51 from the rule of divisibility of 3. So if the sum of the digits is divisible by 3, okay, then the number is divisible by 3. So 5 plus 1, that is 6. So 6 is divisible by 3. That means 51 is divisible by 3. Okay, so and 3 goes in 5 once. Okay, remainder 2, and 3 goes in 21 7. So that means apart from 1 and 51, we still have 3 and 17 as factors of 51. So 50 is not a prime number, 51 is not a prime number. Obviously 52 is not a prime number, because apart from 1 and itself, 2 can go, right? So if 2 goes in 52, 2 goes in 5, 2 times remainder 1, 2 goes in 12, 6. We still have 2 and 26. Okay, so 52 is not a prime number. Let's look into 53 here. So 53 is a prime number. Why? Because apart from 1 and 53 itself, there is no any other number that can divide 53. So it has only 2 factors. So I can pick 53 here. Okay, so if you go, the next one will be 54, and 54 obviously is not a prime number. 55 is not a prime number. 56 is not a prime number. 57 is a prime number, right? So 57 is a prime number, right? Let's see. So if 1 and itself, that is 157, is there any number that can divide it? Obviously 2 cannot divide it, because the last digit is not divisible by 2. Let's check 3. 5 plus 7, that will be 12. Wow. So 12 is divisible by 3. So that means 57 is divisible by 3. So 57 is not a prime number. So you have to check, okay, apart from 1 and 57 itself, so 3 can go into 57, okay? You can see, since the factors are more than 3, you don't need to disturb yourself. So 57 is not a prime number. So the next one will be 58. Of course, it is an even number. So apart from 1 and 58 itself, 2 can go. It is obvious, because it is an even number. So what about 59? So 59, apart from 1 and itself, okay, there is no number that can go, right? So let's see, 2 cannot go, obviously, okay? And if you add 5 to 9, you have 14. And 14 is not divisible by 3. That means 59 is not divisible by 3. It's not divisible by 4, not divisible by 5. So there's no any other number. So another option is 59. So the prime numbers between 50 and 60 are 53 and 59. So you can pick any of the 2 numbers. Let's go to question number 4. So here you have 22, 17, 25, 41, 39, and 4. Work out the difference between the 2 prime numbers in the list above. So before you can get the difference, you need to find or identify the 2 prime numbers in the list. Then you can find their difference. So obviously 22 is not a prime number, 17 is a prime number, 25 is not a prime number, 41 is a prime number, then 39 is not a prime number, 4 is not a prime number. So we have 41 and 17. So you just have to find the difference now. You can say 41 minus 17. So we borrow 1 from here, you have 3, you put it here, making 11. 11 minus 7, you have 4. 3 minus 1, you have 2. So you have 24 as the difference between the 2 prime numbers. So let's go to question number 5 here. So we have to write down a number between 60 and 70, that is Roman figure 1, a square number. So here, you know what a square number is, okay? That is when you multiply an integer by itself, the product is a square number. So you have 1 by 1, that is 1 is a square number. You have 2 by 2, you have 4, 4 is a square number. 3 by 3, you have 9, 9 is a square number. 4 by 4, you have 16, 16 is a square number. 5 by 5, you have 25, 25 is a square number. you have 6 by 6, you have 36. 36 is a square number. Okay, so I'm trying to get a square number that will be between 60 and 70. Okay, so I can get the answer directly, but I'm just doing it so that it will serve as a revision for those that missed the last class. So the next one will be 7 by 7, that will be 49. 49 is a square number. You have 8 by 8, that will be 64. 64 is a square number. So you can see 64 is the first square number between 60 and 70. So the next one will be 9 times 9, that will be 81. Okay, so which is out of this boundary. So our correct option here is 64. Then we need a prime number between 60 and 70. So if you write here, 60 obviously is not a prime number, you know the reasons. Then 61, is it a prime number? Yes, because apart from 1 and 61, there is no any other number that can divide 61 successfully. So you can put 61 here. Okay, what about 62? Let's check. So that's our answer in case you need another one. Okay, 62 is not a prime number, you know the reasons. 63 is not a prime number. 63 is not a prime number, you know the reasons. 64 is not a prime number. 65 is not a prime number. 66 is not a prime number. 67, yes, is a prime number. So, or you can pick 67 here. If you don't want to pick 61, we only need 1. Okay, what about 68? It's not a prime number. 69 is not a prime number. 70 is not a prime number. So that means between 60 and 70, we only have 2 prime numbers, which are 61 and 67. So you can pick any of the two. You can pick any of the two as your answer. So the next one will be a common multiple of 4 and 17. So let me give you a minute for you. I want you to attempt this. Let me give you a minute to attempt this. So, okay, here you can see that to get the common multiple of 4 and 17, so that was explained, okay? So you need to list multiples of 4, then you list the multiples of 17, okay? So you now look for the common multiple of 4 and 17 that will be between 60 and 70. Okay, so if you want to list the multiples of 4 here, okay, so here let's say you want to list multiples of 4, okay, there's a shortcut to that. So if you don't want to do it, so let's write this one first. Multiples of 4, okay, it will multiples of 4 are, you have 4 times 1, 4, 4 times 2, 8, 4 times 3, 12, 4 times 4, 16, 4 times 5, 20, 4 times 6, 24, 4 times 7, 28, 4 times 8, 32, 4 times 9, 36, 4 times 10, you have 40, you have 44, you have 48, you have 52, you have 56, then you have 60. Okay, so that is between 60, and 70. So that means your answer can never be in any of the following because they are out of the boundary. So that means your answer will be from 60 and above now. Okay, you have 64, you have 68. Okay, so that means your answer will be between these three. Okay, so let's try to get multiples of 17 now. Okay, so to get multiple of 17, okay, so you have to multiply it by, let's write here, so you can say multiples of 17. In this case, multiples of 17 will be, so you can take your calculator if you cannot do it offhand, okay, or if you want to have your answers on time. So it will be 17 times 1, okay, you'll be 17. So if you do times 2, it will be 34, okay. So if you do 17 times 3, so it will be 51. If you do 17 times 4, that will be 68. Okay, so you can see now we have multiple of 17 to be 64, then another multiple of 4 to be 68. Okay, so the common multiple of 4 and 70 in between 60 and 70 is 68 here. Okay, so you have 68 as the common multiple of 4 and 17 in between 60 and 70. So let's look into another question here. So here are 5 number cards: 1, 2, 6, 7, and 8. So place 2 cards side by side to show 1, a 2-digit multiple of 7. Okay, you can see these questions are very simple. Okay, so and they are found in paper 1 of any Cambridge exam. Okay, so for the IGCSE, you know, you have you're going to have these papers. You're going to have 1 1, 1 2, 1 3. You're going to have 2 1, 2 2, 2 3, 3 1, 3 2, 3 3, 4 1, 4 2, and 4 3. Okay, so this is paper 1 for core students. Okay, this is paper 1. Any of these 3 will be paper 1 for core students. So you can see questions like this in this component, in this set. Okay, so then this one will be paper 1. Okay, this one is for core students. So this will be paper 1 for extended students. Okay, extended students. Okay, core students here, let me write this properly. So core students are students that are weak, that are struggling with mathematics or with any of their subjects. Okay, while extended students are students that are above average. So core students are below average. So Cambridge tries to differentiate their assessment. So here 3 1, 3 2, 3 3 will be paper 2 for core students. So this and this are for core students, that is students that are below average, while this and this, okay, are for extended students. Okay, that is students that are above average. Okay, so if you want to see it, you can only see it in this will be paper 1 and paper this will be paper 1 and paper 2 for core students. Okay, let me circle them. They are papers 1 and 2 for core students. Why this let me use a rectangle, and this will be papers 1 and 2 for extended students. So questions like this are seen in paper 1, be it core or extended students. You see questions like this, okay? It's just from simple to complex, okay? So now let's go back to the question. We want to form a 2-digit multiple of 7. So can you give it a try? And you can send your answer in the live chat. So let's see if you can see any participants that want to show interest in the question. So you can type and send your solution here. Okay, so let's go back to the question here. So a 2-digit multiple of 7. Okay, so multiple of 7, you know them. You have to do 7 times 1, 7. Okay, let me write here. 7 times 1, 7. 7 times 2, 14. 7 times 3, 21. 7 times 4, 28. 7 times 5, 35. 7 times 6, 36. 7 times 6, 42. I was carried away with the counting, okay? So these are the multiples of 1, 2, 3, 4, 5, 6. So these are the first 6 multiples of 7, okay? So now with the given cards here, so which of these cards, any two, you can combine to form any of these numbers here, okay? So we can, it must be a 2-digit, okay? So otherwise 7 will have been our answer, but we need a 2-digit. So we can get what? Can we get 14? No. Can we get 21? Yes. So you put 2 here, you put 1 here. Okay. Can we get 28? Yes. If you like, you can choose 28 as your answer. Can we get 35? No. We cannot get 35. Can we get 42? No. We cannot get 42. So these are the available options. You can pick any of the two. Then the second one will be a 2-digit square number. So you know the square numbers. They are 1 times 1, 1. 2 times 2, 4. 3 times 3, 9. 4 times 4, 16. 5 times 5, 25. 6 times 6, 36. 7 times 7, 49. 8 times 8, 64, and so on and so forth. Okay, so let's see. The first 2 digits here is 16. So can we get 16 here? Yes. We can pick 1 and 6. So what about 25? No, we cannot form 25 from the given cards. What about 36? No, we cannot form it from the given cards. What about 49? No, we cannot form it from the given card. What about 64? No, we cannot form it from the given card. The next one will be 9 times 9, 81. Yes, we can use 8 and 1. So this is how to get the this is how to tackle problems like this, okay? So the next one, Roman figure 3, it will be a 2-digit cube number. So you know cube numbers, you multiply a number, an integer by itself 3 times, then you get what we call a cube number. 1 times 1 times 1, you have 1. 2 times 2 times 2, 2 times 2 times 2, you have 8. 3 times 3 times 3, you have 27. 4 times 4 times 4, 4 times 4 times 4, you have 64. 5 times 5 times 5, you have 125, and so on and so forth. So let's see, the first 2 digits here is 27. Can we form 27 from the given cards? Yes, 27. Okay, which other one? Can we form 64? No. Okay, obviously you cannot use 125 because it is a 3-digit number. Okay, a 3-digit cube number. Okay, so our option here is available option here is 27. So the next one will be a 2-digit prime number, if you want to form the prime numbers, you have 1, you have 2, 3, 5, you have 7, you have 11. So you cannot form 11 because you only have one card for 1, okay, and you cannot repeat it. The next one will be 13. So we cannot form it because we don't have 3 there. The next one will be 17, okay, so we can do that. So it will be 1 and 7, okay. So you just have to check and see if you have questions there, okay. So this will be 1 and 7 here, okay. The B part of it is write down all the numbers in this list that are irrational numbers, okay. So root 2, yes, is an irrational number, comma, 5.85 is not an irrational number. Why? Because you can write it as a fraction, and that will be 585 over 100, okay. So this is not. How about 4.1 squared? Yes, it is. It could be written as a fraction, okay. By the time you find square root of 4, if you find the square of 4.1, okay, that's by saying 4.1 times 4.1, that will give you 16.81. Okay, sorry for that disturbance there. Okay, so if you do that, 4.1 times 4.1, that will be 16.81. Okay, so that will be the square of 4.1. So 16.81 could be written as a fraction. That will be 1681 over 100. So it is a rational number. So the second one will be a pi here, okay, because it is non-recurring, non-terminating, non-recurring decimal number. So these are the two numbers there that are irrational numbers. It's already 6:30 here, so let's quickly look into the remaining two, and that will be the end of the live lesson. Okay, so complete these statements. The reciprocal of 0.2 is dash. Look at it. 0.2 is equals to, as a decimal fraction, is same thing as 2 over 10. So the reciprocal will be what? 10 over 2, which is the same thing as 5. So this was discussed in our live lesson last week. So the reciprocal of 0.2 will be 5 there. Okay, it's just to flip the numerator and the denominator. So a prime number between 90 and 100 is dash. So if you look at it here, what about 91? So 91, is it a prime number? So if you check, it's not divisible by 2, it's not divisible by 3, it's not divisible by 4. So you can pick 91, and you can try to check. 92 is not a prime number, 93 is not a prime number, 94 is not a prime number, 95 is not a prime number, 96 is not a prime number, and the next one is 97. Okay, so you can pick 97 as well. So I've chosen 91. Then the B part, 7 over 5, 0.6, root 7, 8, and root 9. From this list, write down an irrational number. This is not an irrational number. This is not an irrational number. This is an irrational number. This is not an irrational number. This is not an irrational number, because square root of 9 will give you 3. Okay, so the correct option here is root 7. So let's go to the 8th question, which is the last one here. So here we have this list, and from this list of numbers, you have to write down 1, a multiple of 24. So multiple of 24 will be 24 times 1, that will be 24. So you can take your calculator and press 24 times 2. It will be 48. Okay. So we can do times 3. You have 72. So 72 is the third multiple of 24. Okay, a square number. So which one is a square number there? We know 7 times 7 is 49. So we'll pick 49 here. A cube number, obviously, we only have 8 here. That is 2 times 2 times 2. And a prime number, in this case, will be 17 here. Okay, and then that's the last question there. Okay, so this is already 6:33. Sorry, I started somehow late because I just returned from a transit. Okay, so next week, Friday, we're going to meet again by 5:30 West African time. Okay, we'll be looking into another concept now. So another topic. We are done with topic 1. So we're going to look into another topic. Okay, and then that's going to be interesting. So we're going to be looking at set theory. Okay, so if I'm not mistaken, because I've already prepared the scheme of work. Okay, so I think it should be set theory. So where we'll be discussing everything you need to know about set theory, Venn diagram as stipulated by Cambridge Assessment International Education for IGCSE. So should you have any question, you can reach me via my YouTube channel, or you can simply send a message on WhatsApp, or if you have any topic you want me to make any video, or if you need further explanation, or you need more assessment on this, okay, so you can reach out. I'm always available. So tomorrow we'll be meeting by 4:30 West African time, and we'll be discussing how to supplement teaching with technology for educators. We started last week Saturday, and we are still on Google Form. So tomorrow we are going to complete it, and I'm going to give you a task that you are going to create a task. You are going to create your own Google Form for registration and for assessment. You share it with me as a collaborator, and I can comment on it. Okay, so don't miss the class tomorrow by 4:30 West African time till 6:30 West African time. That was 2 hours. Okay, so until tomorrow, enjoy yourself, have fun, and if you are new, you can subscribe to my channel, and if you are a returning subscriber, you can share it with your friends. Let them enjoy this. I intend to give more content regarding mathematics and supplementary teaching with technology, so you can don't limit it to yourself. Share it with your friends that are educators, or if you have students that want to write IGCSE exam, so maybe in the next 2 years they can follow up, because I'm following the syllabus as stated by Cambridge from beginning to the end. That is what I intend to do. Okay, by the end of these live lessons, students should be able to write the exam IGCSE mathematics conveniently, and an educator should be able to teach all the topics conveniently as well. So until we meet tomorrow, enjoy yourself. Bye.